Hello everyone, welcome to Sir Rob's Math Lab. Now today we're going to look at this geometric proof question. So here we have PQRS is a cyclic quadrilateral, QS is equal to QR, VST is a tangent to the circle. Now the question is asking us to work out the value of x and you must show all working. So here, let's look at the diagram here. We have a circle, we have a cyclic quadrilateral inside the circle, we have a tangent. Now, whenever you're given this type of question, the very moment you see a tangent, you must think about the tangent theorem. Good. Now, when we're doing circle theorem, we came across some theorem that has to do with the tangent. Now, one of which was angle at this, well, not angle formed between the radius and the tangent is 90 degrees. So that is one of the theorems. Now, if we look, we do not see any radius here. So we cannot use that radius tangent theorem. Now there's also another theorem that has to do with the tangent. We state that the angle formed between the tangent and the chord is equal to the angle formed at the circumference in the alternate segment. All right, so here we have the chord, here we have the tangent. The angle is formed between the chord and the tangent, so it must be equal to the angle formed at the circumference in the alternate segment. So it means that here has to be 2x as well. So here we have 2x. Now let's go. So from you see these two lines, it means that these two lines, they are equal. So once you see a line going through these two lines, it means that these two lines are equal. So once you're looking at a triangle and two lines are equal, it means that the two of the angles are going to be equal. So it forms an isosceles triangle, and base angle of an isosceles triangle, they are equal. So we can go ahead and see if we can find this angle QRS. So let's go ahead and try and find QRS. So QRS, so we're trying to find angle QRS. Now the total angle in a triangle, you know, it adds up to give you 180 degrees. Now to find the missing angle, you're going to subtract this known angle here from 180, and then you're going to half it to find this bit right here. Now remember, these two, they are the same thing, so that's why we go ahead and half it. All right, so it is 180 minus 2x, and we're going to half it to get angle QRS. Now if we go ahead and half it, now we're going to get 90 minus x. All right, so angle QRS is 90 minus x. So let's go ahead and put this in the diagram. So that's 90 minus x. So that is angle QRS. Now, this is a cyclic quadrilateral, and we know for a cyclic quadrilateral, opposite angle in a cyclic quadrilateral, they add up to give you 180 degrees. All right, which means that angle SPQ plus angle QRS must be equal to, well, it's going to add up to give you 180 degrees. All right, so we know that angle SPQ is 7x, and angle QRS, that's 90 minus x, and it should be equal to 180 degrees. Now let's go ahead and solve. Well, simplify this side, then we solve. So 7x minus x, that's going to give us 6x. So we have 6x plus 90, which is equal to 180 degrees. Good, so we're going to subtract 90 from both sides. So 6x is equal to 180 minus 90. That's going to give us 90. Then we're going to divide both sides of the equation by 6. All right, so 6 cancels the 6. So x is equal to 90 divided by 6. 90 divided by 6, that's going to give us 15 degrees. So angle X is 15 degrees.